Hi folks, welcome back. If you're new here, please consider subscribing. It would really help out my channel a lot. As you can see here, I've got an old kiln. This is a ceramics kiln because I also do ceramics. And what I wanted to do, so this kiln currently has what's called a kiln sitter. And what this does is basically it sets a button. There's an actual cone inside made of ceramic that hold up a little switch. And when that cone melts, when it's reached temperature, the switch pops, this drops, it turns it all off. And then you can ramp up using these two things here. What I wanted to do is make an electric thermocouple, which is a thermocouple tells me what the actual temperature inside here is. The other thing that ceramicists like to do, especially if there's a specific glaze or any clay body that we're using, we like to hold at certain temperatures. So there is a way to do that with the old-fashioned kiln sitter, but what I want to do, at least for this first step, is have the thermocouple, the electronic bit that's telling me, I want it to tell me the actual temperature as it's rising in temp. I want it to be able to tell me that from a distance, so I want to be able to see it on a website or on my phone. And lastly, when it reaches that target temperature, whatever I set it to, I want it to alert me using a text message to my phone so that I can say, oh, the kiln has reached temperature, now I've got to get in there and set it up to soak. Later down the line, I think we're going to make this into a fully automated kiln, so I can add a couple more components and it'll add that to it. So first, let me show you the inside. What I've done, this kiln operates on 240 volts. That's a lot more than 120. So I have a little component that will change the 120 volts into, actually I can do up to 240, but I'm going to do it with 120 into, that will change that into 5 volts, which will run the little microcomputer or microcontroller that I'm using, as well as all the rest of the components that are going to go into this. It's actually going to go onto this. It's going to be on the outside, because out here, this part gets very hot. Inside the kiln gets up to 2,300 degrees. Outside the Fahrenheit. Outside the kiln, right here, doesn't get very hot at all. In fact, we can touch these controls without burning our hand or anything else. So this is where I want to install my controller, because it's electronic and I don't want it to get too hot. But I think on the outside of this, it should be okay. But we'll see. I'm going to test it. Okay, so here's the exciting part. These are all the components I'm going to use. These are really inexpensive. This is the brains of the operation. This is a Wemos D1 Mini. The Wemos D1 Mini can do Wi-Fi. That's what this little antenna and this thing is. It's also a microcontroller just like an Arduino. It works on 5 volts. This is pretty obvious. It's the 4-digit display. This is going to go on the outside of the kiln and show me the exact temperature of what it is when I look at the kiln. It'll also flash when the kiln reaches temperature. This little guy is what changes the 120 volts into 5 volts transformer, which will take in the line power and change it to 5 volts. This little guy here is actually it's a Max 6675, but I'm going to have to upgrade that because the Max 6675 does not get hot enough for the kiln. So this little component will have to be upgraded. But again, these are only about $2, and the upgrade is about $2. So there you go. And this last piece, this long piece here, is the thermocouple. It's got wiring that I just have twisted tied there, but you can see from the nut to the end here, that's what actually goes inside the wall of the kiln. And I'll show you when I set it up, but I'm just going to set it up temporarily first to try it out and make sure it works. Now I have made the all of the software so far, and I'll share that. Now before I get into this, just to clarify, this is high voltage. It is not safe to work with. If you've never worked with home voltage before, stop now. This project is not for you. This is just for entertainment in that case, okay? So the way 220 volt or 240 volt works here in the United States, with single phase. So we take the 3 wires. These 2 wires are both hooked each to a 110 ground line, or 120. It varies in the United States. This is obviously your ground. This is line, this is line. Up here in this coupling, you can see, by the way, it's unplugged and moved away. This line, line 2 and line 1, these run 110 volts each. So I can have the voltage to my little voltage regulator, my little transformer, into 120 if I go from line 1 and to ground. And that's okay. Just running a quick test. This is my little voltage converter. It's taking the 110 out of there, which indeed is 110. I just connected it temporarily with some wire nuts, and sure enough, it's pushing out exactly 5 volts, 5.02. So that's 5 volts, and that will run the system for this test. Okay, so we're about ready to do our test. What I have going on here, I've got the thermocouple jammed in with the block for the vent hole. I've got the entire system is double stick taped to the front of this. So that way, if this gets so hot that that the double stick tape loses, you know, whatever, it'll just fall. And I think by falling to the cool concrete, it'll keep it nice and cold if it gets to overheating temperature. Now, overheat temperature for these components is somewhere around 70 to 100 C. That is somewhere around 160 or so to about 220 or so degrees, which we're going to try to keep it down closer to the 160 or below if we can. That's around 70 C, which 60 to 70 C, which is normal operating temperature for most of these components. So that'll be the test to see if it can withstand the heat, which is mostly what this test is for. Now I have the power coming out of here, going to that, which we tested before, which then goes into my power bar here, which is running all the components. This is all just temporary. It's just a test to see if it works. Proof of concept, sort of. Okay, so it is plugged in but not turned on, and my first failure is that that is upside down, but oh well. It's just the way it's going to be. Hopefully everything's connected up, and what I'm going to do is throw the power switch and turn the actual kiln on, and then start following along and see what I can see. Okay, so right now, I know it's upside down, but it's at 560 degrees or so, and I'll show you the temperature of the outside of that. Oh, you can't really see that, but it's reading 76 degrees right here. There you go, 77 now. These parts are virtually not getting anywhere. It's literally just room temperature. To switch that into centigrade, it's 22 degrees. So right here is so far 24 degrees. We'll see how high that gets. As it goes up, it's going to get to 800 degrees on the inside before the alarm, well, 752 degrees on the inside before the alarm goes off. That's Fahrenheit. That's 400 degrees centigrade. Now I'm going to reset the max temperature. I'm going to bring it up to, I don't know, 798 centigrade on the inside, and then it should blink again. Okay, I realize that the temperature gauge is upside down, but you can see it's over 1,000 degrees. It's 1,076, 78 degrees now, and this part is still only like 70 degrees, if that. It's cooler than my skin right now. So out here, nothing. It's like 65 degrees. It's, like I said, the maximum that these components can deal with is somewhere in the 60 to 70, I'm sorry, 60 to 100 degree range. I'm talking centigrade. 60 to 100 degrees centigrade. And right now it's less than 30 on all these components. That's nothing. I can touch this, no problem. So there you go. When this does get up to 1,468 degrees, which is going to be 800 degrees centigrade, that's a little bit more than half of the total temperature that this kiln can get to, or that I want to get to. It's 800 degrees centigrade. Cone 5, which is what I normally run, is about 1,200 degrees centigrade. So when it gets to that temperature, we can extrapolate. We can get the temperature of this and find out roughly what temperature it will get up to, and that'll help me prototype a box for this and see if I have to add a fan or anything. I might add a fan anyway. Okay, so this is my controller, and there's a temperature and a little fan to keep everything cool. That'll be locked in and everything, but I haven't gotten the proper... this is I think it's a 6675, and I need the upgraded version that can go a little higher so it can be kiln level. This is the SSR that I'm connecting. These lamps are connected to currently, but it's just showing the off and on of the SSR. So that will be powering the coils, and it is, I kind of overdid it with the programming, as usual. So I made it so that the program can actually control the SSRs and bring it up at a ramp value. So it'll bring it up like 100 degrees. And so it's testing what's coming in on the probe. Now I have two probes. This one's the higher temperature probe. This is the lower temp probe that I've got right now. I think this can go up to like 1,000 C, and this can go up to 1,500 C, sorry. And so that should be plenty for this. This kiln only goes up to about 1,200 C, and actually even then it usually only does about 1,165 or something. So this is my really bodgy wiring setup. I'm just testing it outside. So what I'm going to do is the controller box will be connected to one of these lines. So that's what this little white cable is. That is actually going to give it 120 volts, although the controller box can do up to 240. And the same thing with the SSR. The SSR is a switch that is controlled by the 3 volts coming out of the controller box, so that can turn it on and turn it off at will with just 3 volts. It's crazy. This is the 120 going in. It's separating it. Obviously, this is good for up to 380 volts and 40 amps, which all I'm pulling is about 24 amps all on with this particular system. So I'm going to... This system, basically, these are the 2 lines going in. These are the 2 hot lines. The ground goes directly to the case. So the 2 hot lines going in. And what I can do is actually connect the controller in between. The SSR will go in between this hot line, because the whole thing is a loop. And it all goes back and around. So you're basically, this is the cone contraption. So it's basically going from L1, which you can see down here, to, L2 and L1, and it goes around in a circle. So I basically have to break that circle right here and put a switch in between. So the switch is going to go to this, and then these wires are going to go to the other side of the switch, and that's it. So what I can do later on is set up 2 SSRs. We'll have to separate these two. So I'd basically have 2 SSRs going to this. One of them going to this wire, and then the other one going to this wire. And that would control them separately. However, oops, did I not get that in? This wire and this wire would be separate in a dual system, which something like that I can. But so far so good. This fan, obviously just running off the 5 volts that are coming in. So this is the converter for the 120 coming in. That converts it down to 5 volts. The 5 volts then goes through the D1 Mini. After all of this, this is basically, I have in line with it, I've got, you can just see if I can get it in there. You can just see there's a resistor, a capacitor, and in between the two is a Zener diode, which will act basically as a smoothing agent, especially with the capacitor. It's a 16 volt, 1000 microfarad capacitor, which brings the 5 volts. It keeps it from being any spikes. It smooths out from this power bank. It'll smooth out those voltage spikes, and it protects basically my little D1 Mini here. And that's fundamentally it. This is the back side of the display and the fan. So I'm going to get this all installed, and I'm going to do a test run on the actual kiln. Okay, this is the part I don't want you to do if you don't know what you're doing with electricity. Electricity, 220 volts, 230, 240, whatever, is not something to play around with. So you've got to know what you're doing. Okay, so what I did here, I set up the 2 SSRs, which are these solid state relays. You see them, I have them labeled top and bottom. That means the top and bottom coils, which coincide with the top and bottom connectors for the top and bottom coils, if that makes any sense. So there's a coil, another coil connection here, here. This is the bottom coil. They're connected here at the other end, and they go up to this lower coil control. This goes to the dial that tells you the percentage to turn it on and turn it off. This has an extra little connector right here. You can barely see it. And then same with up top, extra little connector. These are the 2 connectors that are then going to be connected to the SSRs. This side of the SSR is the 3 volt control side, which will be coming in from the controller. Then I have these sides, the one side from the AC, from the SSR, going up to the L2 connector, okay? That means it's going to get 120 volts for each coil, right? And then this acts as, this is the return line for that, right here in L1, is the return from both coils, that one and that one. So they come down, return. All of this goes into these 2, line 1 and line 2, which goes out to the cord. This is the ground. The ground grounds to the frame. We're also going to use that ground for our unit. I also, if you'll notice, I connected underneath for each of the SSRs. I have them connected through the metal, which will act as another heat sink, the actual aluminum heat sinks, and I'm hanging it out the bottom of the kiln because obviously that's the coolest area this close to the kiln. So it's stood off away from all the major wiring is going to go away from the kiln. The lower voltage wiring will go up this way and then out to the control box. Okay? So that's the start of the control wiring. You also may notice that I moved both SSRs over away from where the major wires come in. These wires are going to be well away from the SSR. It does tend to heat up. I mean, I know the kiln is heating up anyway. And these are heat-resistant wires. All of these, you'll see these outside sheaths are actually made of fiberglass. So they're pretty heat-resistant. I have more of that heat-resistant stuff that I'll use running up to the control box from within here. So all these are going to be that same heat-resistant wire going up to the major coil connections. Okay. Okay, like, comment, and subscribe, please. I really could use it. Give me a thumbs up, all those things. Also, be sure to stay tuned for the second half of this, where we actually build the rest of the controller, do the software, and I show you how it all works. Thanks for watching.